Okay, in this video, we're going to be solving quadratic equations by factoring. And the main difference between this video and my last video on factoring, just factoring expressions, is that in this case, instead of just having the expression ax squared plus bx plus c and then factoring that, now we have an equal sign. And so that equal sign tells us that we can actually solve for x now, which is kind of cool. All right, so a, b, and c need to be real numbers, not imaginary numbers, and a can't be 0. So if you just have the bx plus c, this is not what you would use. All right, so an example is that, let's say you have this quadratic, okay, and then you factor it out. Well, before we would just stop here at the factoring part, but to solve it, we want to know what is x, okay? So the first thing we want it to be is that it's equal to 0, and this one's equal to 0. So we're going to use something called the zero product principle. What that means is that if you have two things multiplied by each other and it's equal to 0, if the first term is 0 or the second term is 0, it makes the statement true. In other words, 0 times something is going to give me 0, or if this is 0 times something, that's going to give me 0. So basically, if either one of them is equal to 0, it's going to make the statement true. So in this case, this whole expression is set equal to 0, and the other whole expression is set equal to 0 to find out the two scenarios for x that would make the statement true. So we solve for x just like you would before, and then we put our answer in set notation. We always list our answer in set notation from the lowest number, if you think about it on a number line, to the highest number. So whatever's least comes first, and then whatever's more on a number line comes second. And they both could be negative. Like you could have a -10 and a -8. That's fine, or two positives, or 0, or it doesn't really matter as long as it's from lowest to highest. Okay, so you'll know that you're going to do more than factor, because in this case it doesn't say factor, it just says solve. And in this case we're going to solve by factoring. All right, so we're going to use the AC method, which means we're going to multiply 2 times -4 and get -8, so that we can find our factors of -8. Well, since it's negative, one of the numbers is going to be negative and one's going to be positive. So -2 and 4, 2 and -4, so forth. Okay, so these are the factors of 8. What we want to do is find the sum that adds up to +7. So -1 and 8 actually equal to +7. So I could have stopped there. Okay, so these are the two. So I'm going to do this. I'm going to rewrite the middle term, 7x, as -x and +8x. That's all I'm doing. So I didn't change the value of the first term or the value of the last term. I simply rewrote the middle term differently, but it's still the same value. Okay, so, and the reason I'm doing that is because then I can factor by grouping. Okay. All right, so we're going to use two terms. So what's in common with these two terms is an x. What's in common with these two terms is a 4. So I'm going to factor out an x. Okay, keep my equal sign in there. Now I could have written the 2x minus 1 first and then the x plus 4, or vice versa. It doesn't really matter. Okay, now the zero product principle says that if either the first term that's in parentheses or the second term, because they're being multiplied, if this thing is 0 or if this thing is 0, it will make the statement true. So I'm going to make x plus 4 equal to 0 or 2x minus 1 equal to 0 to solve. Remember, we're trying to solve for x. So if I subtract 4 from both sides, I get -4. If I add 1 to both sides, and then I'm going to divide by 2. Okay, so x can either be -4 or a half. And if you plug those back into the original equation, they'll actually work. So I'm going to put my answer in set notation with the lowest number first, and a negative number is going to be lower than a positive number, even though it's a fraction on a number line. All right, let's look at this example. Now this example isn't equal to 0, so I've got to rearrange it. So I've got to subtract 6x from both sides, and I need to add 9 to both sides. Okay, so I get x squared minus 6x plus 9, and then this becomes 0 because those cancel out to be 0. All right, so now There's no greatest common factor. There's nothing I can factor out of all three. So I'm looking for 1 times 9 is 9. So I'm looking for factors of 9 that'll give me -6. Well, I start thinking about 3 and 3, right? So 3 times 3 is positive 9. But that doesn't give me a -6. So if I make both of them negative, -3 times -3 will give me a positive. But when I add them, I'll get a -6. So that makes it kind of nice. So I'm going to rewrite the middle term as 2 middle terms, but not change the first or last term. So I'm going to see what's in common here. Remember, if the first term that you're working with is negative, you have to divide by a negative. Okay, so then we have x, and then x minus 3 times x minus 3. Now, the reason this is minus is because a positive 9 divided by -3 is a negative. Like positive divided by negative is negative. Okay, so then I'm just going to rewrite it as 2 factors. Now, what we notice about these 2 factors is that they're the same. So x minus 3 equal to 0. I don't need to say or x minus 3 is equal to 0 because it's the same thing. So I can just use it one time. So I add 3. So if x is equal to 3, it makes this equation true. So in my answer, I'll just write 3. Now later when we graph this polynomial or this trinomial, we'll notice that it's tangent at x is equal to 3 on the xy axis, okay? All right, so at 3, the quadratic is going to be facing up, right? And it'll actually touch at x is equal to 3. So we'll get into that later because we'll use this information to graph. Okay, let's do a few more. Okay, again, this one's kind of different because we're going to move this to the other side. So 3x squared minus 2x is equal to 0. Well, you notice there's no constant, there's no c. But we can factor something out of both. Like we're looking for a greatest common factor. And in this case, both of them can be divided by x. Okay? Now, this looks kind of weird, so a lot of people just ignore the x, but you can't do that. So there actually is something, and we can put in x in parentheses just because then it makes it look a little bit more like what we said before regarding the zero product principle, so that it looks more like an a times a b, like something times something is equal to 0. So x times something is equal to 0. The difference is that x is just a monomial and this is a binomial, so it doesn't really matter. So we're going to use the same zero product principle if this one is equal to 0, or if this one's equal to 0, it makes the statement true. So one of the answers is that x could be 0. The other one, we're going to add 2 to both sides. Okay, so x can either be 0 or 2/3, and when we write it, we're going to write the lowest number first, and then the highest number, so 0 is lower than 2/3. All right, let's look at this one. 9x squared minus 16 is equal to 0. I subtracted 16 from both sides. Now, if you'll notice, this is in a format called the difference of squares. Okay? And the difference of squares means that you have a perfect square, something that was squared, and then you subtracted another square. That can always be factored into a minus b, a plus b, because that middle term ends up canceling out to be 0. So all you're left with is the a squared and then the negative b squared, okay? So we notice, what is a here? There's a 3x squared and there's a 4 squared. So we've identified what a is because 3 squared is 9, x squared is x squared, 4 squared is 16. All right, so now that we know what a and we know what b are, we can put them into this factored form. And again, you can say 3x minus 4 times 3x plus 4, or you can say 3x plus 4 times 3x minus 4. The order of these don't matter because they're being multiplied. Just like 3 times 7 is the same as 7 times 3. So it doesn't matter the order. So we're going to use our zero product principle and say if the first one's equal to 0 or the second one's equal to 0, it makes the statement true. We're trying to solve for x. What would x have to be to make this statement true? Okay, so then we're going to add 4 to this side and then divide by 3. Okay, we're going to subtract 4 from both sides. Okay, all right, so in our answer, we'll put the lowest number first and then the highest. And since a negative is always going to be lower than a positive, that's what we'll do. All right, now we're going to apply this to this zero product principle and solving for quadratics to a real world problem. So we have this architect and he can only have 15 square meters to add to a small bedroom. And so because of the design, the width must be 7 meters less than 2 times the length, and so we want to find the dimensions of the room. The area is what we'll the formula that we'll typically use in these quadratic real-world problems. So first we need to write an equation for the width. We're going to translate from English into algebra. So it says the width is 7 meters less than 2 times the length. So we've got 2 times the length and then 7 meters less, okay? And the area is going to be 15 square meters, okay? So we're going to put in 15 for area, and then the length is going to be length, and the width is actually going to be written in this form. Now the reason we're going to substitute, instead of W, we're going to substitute this whole expression for W is because in this equation I can only have one variable to solve for. If I have L's and W's and A's in the same equation, I can't solve for anything. I need to have only one variable so that I can solve. So I'm going to rearrange this, and the reason is because I like to have my variables on the left. So I'm going to distribute the L, so I have 2L squared minus 7L is equal to 15. That looks kind of weird, but think of it in terms of an x squared. Okay, we're used to having x squares and y squares, but L's can be squared too. So I'm going to subtract 15 from both sides. Okay. So now I have what looks like a quadratic, like 2x squared minus 7x minus 15. Now how would I solve this? There's no greatest common factor. 2 times negative 15 is negative 30. And I want factors of negative 30 that will give me negative 7. So I have negative 3 and 10. That gives me positive 7. But if I do this, I get negative 7. Okay? So I'm going to rewrite this, 2L squared plus 3L minus 10L minus 15 equals 0, okay? So this looks kind of like what we were doing before. So I'm going to use my factor by grouping, okay? Negative 5. Remember, this is negative, so it has to be a negative here. So L times 2L, okay, plus 3 is, minus 5 times 2L plus 3, okay, is equal to 0. All right, and then I'm going to write it as 2 terms, just like I did before, okay? And the zero product principle says that if either the first term or the second term is equal to 0, then it makes the statement true, okay? All right, so I'm going to add 5 to both sides, subtract 3, and then divide by 2. Okay, so we're talking about a real world problem here. So the length is either going to be 5 or negative 3/2. Well, in the real world, we don't have negative lengths or negative widths. So the two solutions are algebraically correct, but only one of them is possible in this scenario, okay? So you can't have a negative length or width in real world. So this would not be what we're looking for. So that means the length is 5. Now that I know the length is 5, I can just substitute it into this equation for width. 2 times 5 minus 7, so 10 minus 7, which is 3. So the length is 3, and the length is 5, and the width is 3. Okay, so let's go back and look. The area, if it's 5 times 3, that does give me 15, so it does check out. So we would write our answer. Length is 5, and since the units are meters, we use 5 meters, and meters is just an M, and the width is 3 meters, and that is the correct answer to the question. All right.